Dear students, in the previous video, I explained the construction part of the optical fiber. In that also, I explained that how the light ray is passing inside the optical fiber. The principle is total internal reflection. And to understand the total internal reflection, first we must know about critical angle. So that concept only we are going to discuss in this video. So first one is how the light actually, this is the optical fiber. Okay, so through this optical fiber, the light signal is passed. The light signal will travel in the optical fiber for a long distance, right? So how the light is confined only in the core medium. Okay, the inner part of the optical fiber is core. So the core only carries the light from one place to other place. So how it is carrying, how the light ray is confined only inside the core medium. Okay, that part is explained by these two things. One is total internal reflection, that is the principle of optical fiber to carry the light from one place to other place. And to understand this total internal reflection, we must know about critical angle. These two things we can discuss with the help of three conditions. Okay, let me explain one by one. One is I and another one is theta. Here I is the angle of incidence. I is the angle of incidence and theta is the angle of refraction. Angle of refraction. Okay, two angles I have given. One is I, angle of incidence, and theta, angle of refraction. So the angle of incidence takes place in one medium, that is core medium. Okay, so where the angle of incidence takes place in core medium, its refractive index is N1, and the angle of refraction takes place in the cladding medium. Okay, takes place in the cladding medium. So its refractive index is N2. Its refractive index is N2. Okay, and then already I said the core is having, that means with the condition of N1 greater than N2. What is the meaning of this? This is denser medium, that the refractive index of the core should be slightly greater than the refractive index of the cladding, so that the core refractive index will act as the denser medium for the light ray, and in cladding it will be rarer comparatively with the core, it is rarer. Okay, this is what we have to understand. So two medium we considered, one is the core medium and another one is the cladding medium. In core medium, incident is taking place. In cladding medium, refraction is taking place. So by using this concept only, we are going to understand critical angle as well as the total internal reflection. Okay, so now this diagram will help you to understand what is critical angle and how the total internal reflection takes place inside the optical fiber. So for that, I am going to consider three conditions. I less than IC. Already I said I is the angle of incidence and IC represents critical angle. IC is nothing but critical angle. Okay, this is first condition and this is the second one. I is equal to IC, and the third condition is I greater than IC, and theta is the angle of refraction. So this is the inner part of the optical fiber, that is the core medium. Its refractive index is N1 and I said it is the denser medium. Okay, and which is surrounded by the cladding. So this is the cladding medium. Its refractive index is N2. It is the rarer medium, right? So now the angle of incidence takes place in the core medium. Okay, the light travels from denser to rarer medium. This is the first condition. The light travels from denser to rarer, denser to rarer. So now this is the normal. The red color line represents the normal. Okay, normal line. So here this is the angle of incidence. Okay, I value. If the I value is less than critical angle, then angle of refraction takes place in the cladding medium. So the theta is the angle of refraction. Okay, this is the first condition. If I less than IC. Okay, now we don't know what is critical angle. The second step we are going to understand. If the angle of incidence is less than critical angle, then the angle of refraction takes place in the cladding medium. The angle of refraction is represented by theta, right? The next condition is I is equal to IC. That is, the angle of incidence is equal to critical angle. How can we define this is the critical angle? Because the angle of refraction, now this light ray is not going to the second medium, it is traverses along the interface. Okay, listen carefully. This is the interface between core and the cladding, between core and the cladding. So the angle of refraction is traveling along the interface between core and the cladding. Now the angle of refraction is theta, which is equal to 90 degree. So now we can explain the critical angle. What is critical angle? Critical angle is the angle of incidence in which the angle of refraction will be 90 degree. The angle of refraction will be 90 degree. This is called critical angle. Okay, once again I will repeat, the angle of for particular angle of incidence, in that way we can say for particular angle of incidence the angle of refraction will be 90 degree. That means the light travels along the interface between core and cladding. So that particular angle of incidence is called critical angle. So now you have the idea about critical angle. Okay, so for example, this I is approximately equal to 25 degree. Okay, for example, and this I is equal to 45 degree. For example, I am saying I is equal to IC. So this angle is less than critical angle. Here IC is 45 degree. That is the reason it travels along the interface. So the angle of refraction is 90 degree. Next, I am increasing. What is the third condition? I is greater than IC. It should be greater than 45 degree. For example, I is 55 degree. For example, I is 55 degree. So at the particular angle of incidence, that means if the angle of incidence is greater than critical angle, the light will reflect inside. Now you see, here it is refracting to the other medium. Here it is traveling along the interface, and further if you increase the angle of incidence greater than IC, it is internally reflected back. Okay, so this condition is the total internal reflection. Total internal reflection. It is not refracting to the other medium, it is reflecting back inside the same medium. That is called total internal reflection. So by using this, the light will pass only inside the core medium, only inside the core medium. So by using these three conditions, we can understand how the light is confined only inside the core medium of the optical fiber. Okay, so now you understood what is this three conditions and how the total internal reflection takes place. Okay, and so what is the condition for total internal reflection? So now I can say the phenomenon of total internal reflection takes place when it satisfies two conditions. What is the first condition? The light should travel from denser to rarer medium. That is nothing but N1 greater than N2. The light should travel from denser to rarer medium. For short answer, you can write like this. The total internal reflection takes place only by satisfying this condition. Which condition? The light should travel from denser to rarer medium. And the second condition is I should be angle of incidence on the core should be greater than the critical angle. Should be greater than the critical angle. So for short answer, you can write these two conditions. Okay, for total internal reflection. Right. Next, I'm going to explain about how can we find the value of critical angle. Then only we can pass the light greater than that. So first we should know how to find the critical angle formula. So let me explain about it. Now let me explain how to find the critical angle. So already we know that two mediums are involved in this. One is the core medium, its refractive index is N1, and the cladding medium, the refractive index is N2. So now to find the formula for critical angle, I am going to follow the Snell's law. Snell's law of refraction. Snell's law of refraction. See here two mediums involved, medium 1 and medium 2, that is core medium and the cladding medium. Its refractive index is N1, its refractive index is N2. So based on this Snell's law, N1, okay, sin I. That means in the first medium only the incidence takes place, which is equal to, next medium is N2 sin theta. N2 sine theta. That means in the second medium, the angle of refraction takes place. Okay. So N1 sine I is equal to N2 sine theta. This is the Snell's law. Where the incidence takes place, that refractive index, and where the angle of refraction takes place, that refractive index. Okay. So now we have to substitute all those values. So here I, angle of incidence, is equal to IC, right? Instead of I have to write IC, and theta. Theta is equal to 90 degree. Theta is equal to 90 degree. This is critical angle, right? Substitute these two values in this. So N1 sine IC is equal to N2 sine 90 degree. Okay, so as you know the value of sine 90, which is equal to 1, I am writing sine IC is equal to, here remaining is N2, this value is 1, this N1 is coming down. Okay, so sine IC is equal to N2 by N1, and then I need only IC. So IC is equal to sine inverse of N2 divided by N1. N2 by N1. So this is the formula for critical angle. So by knowing the value of refractive index of core and cladding, I can decide what is the critical angle inside the core. Okay, so IC is equal to sine inverse of N2 by N1. N2 is the refractive index of cladding and N1 is the refractive index of core. So in this way, I can find the critical angle for the particular optical fiber. Okay, so I hope you understand this. If you have any doubt regarding this, you can ask me in the comment box. Thank you everyone.